A and B, yeah? B is somewhere in the third quadrant, and A is firmly in the first quadrant. So B would be somewhere around, what's it, -1, -2, would be around here. A would be 7 across, 4 up, so A would be somewhere in here. Now, the deal is that the point C, if they're collinear, what would be the deal with the point C? The point C would be on the line. I can't tell where exactly. Do you get what I'm saying? It could be all the way behind A on the same line. It could be all the way down behind B. I actually have no idea what part of the line it's actually on. Is that all right? Now, I think what we could do, you have a couple of options here. I think the first option would you agree that if they're collinear, the area of the triangle will have to be what? The area of the triangle is going to be 0, isn't it? So here's my idea. My idea is we get B, which is -1, -2, and we turn it into 0, 0. What did I do to make that happen? And +2 to y. All right, do the same thing with A then. What's A get turned into? Huh? 8, 6, yeah. Now, what does C get turned into is the real skill. So it says 3t, was it? 3t plus 1 and 7 minus 4t. Okay. Now, if they are collinear, the area of the triangle will be, doesn't exist because it's a flat line. Okay. So that's what we're going to go after. Area equals a half x1, y2 minus x2, y1. Right. So let's go after that then. Okay. What do we get? X1, lads. Okay, so we're going to go for 8, and what else? What's y2? Huh? 7 minus 4t. Okay. I'll choose capital T because my T's look like pluses. Okay, and then the other one? 3t plus 1, yeah? Times 6. Now see that 6? I'm going to combine that 6 with the minus to make it a -6. I'm going to multiply him by -6, okay? And here we go. We're going to have a half. So 56 minus 32t. And then we're going to have minus 18t. What else? -6. And lucky for us, and the area is 0. 2 times 0. So we can just concentrate on this part now. That's what causes it to be 0 at the end of the day. So 56 take away 6 is 50 minus 50t. Okay. There's only one value that's going to do that, isn't there? At the end of the day, it's plus or minus 0. So it's a 0, yeah. So we're only getting one answer. And we all know that t will have to be 1. No, -1 this time. Because 0. So this question requires 2 possible values, which the area of ABC is 25. So instead of an answer of 0, it's going to be an answer of 25. So I'm just going to go where the 0 used to be, and I'm just going to put in 25 here. Instead of 2 times 0, it's now 2 times 25, which is 50. Okay. Now, suppose what we can do here is you could square both sides, but I think that'll be slower than doing this. What'll be the faster way of doing it? 50 minus 50t equals 50, and 50 minus 50t equals -50, and that'll get you the answer a little bit quicker. So I think it's going to be 50t when I move this over. 50t equals 0. So therefore t equals 0. And then the other one, 50t equals 100. And t will equal 2. And there's our two answers. All right. As you listening? All right. Uh, the line 3x minus 4y plus 6 intersects the x-axis at A and the y-axis at B. Find the equation of the perpendicular bisector of AB. Give your answer in the form ax plus by plus c. A, B, and C are whole numbers, negative or positive, right? First thing I like to get into my head is I like to get a gist of what direction it's going in, right? So I tend to use y equals mx plus c a lot. And what I'll end up doing there is I'll end up getting that 4y equals 3x plus 6. And then I'll divide by 4. And I'll get y equals 3/4 of x. That means it's a positive slope, isn't it? Going upwards. And 6 divided by 4 is 1.5. You happy enough with that? Now, I've already discovered one of my points I was looking for. I was looking for where it hits the y-axis. Isn't that right? And what's the c value? The c value is where it hits the y-axis. So what's this? 0 and 1.5. Is that right? Now, next thing is the next thing is I need to find out where it hits the x-axis, right? Now, what we're going to do is we're going to replace y with 0. Is that okay? Replace y with 0, and we get 3/4 x plus 1.5 equals 0. Bring the 1.5 to the other side. What am I going to do with that 1.5 now? I'm going to multiply by 4 to get minus 6, and then I'm going to divide it by 3, and what's going to happen there? Minus 2. Is that right? So that'll be minus 2, 0. Okay, you guys? And that creates the positive slope we were expecting, doesn't it? Now, what does it want from us now? What is a perpendicular bisector? What's the definition of it? Yes, sir. Exactly. So what perpendicular bisector means is that it goes through the halfway point. So you get the midpoint, yeah, using the midpoint formula. That'll be your first thing you want to do. And then the second thing you want to do is you're going to have to find a slope that's perpendicular to the existing slope. Does anybody know what the answer is already? What? You grab your existing slope and you turn it upside down and you change the operation. If it's a plus, you change it to a minus. If it's a minus, you change it into a plus. So what would be the slope? Huh? Minus 4 over 3? Grand. So guys, you can finish that off there. Get the midpoint and then sub it in. Once you find the midpoint of the line, sub it in and you should be able to get that pretty quickly. Off you go. Very easy question, this one. All right, so add them together. It's going to be, add the two x values together. It's going to be minus 2 plus 0. Once you add the two of them together, you get minus 2. Divide minus 2 by 2, minus 1. And then add 0 and 1.5 together. You get 1.5 and then divided by 2. 0 0.3 over 4 or 0 0.75. Okay. Okay. So 0 plus 1.5 and then divided by 2. 0 0.75. Cool with that? Now, we know that this blue line has to go through. It's the perpendicular bisector. So this blue line has to go through. So we have to use this as our x1 and y1. Okay, so what do I put as y1 then? 0 0.75. Okay. And then our x value. Minus 1, which will turn into a plus 1, yeah. There we go. So that's going to be plus 1. And here we go. Okay. Multiply it by 3. Then we get y minus, what's it, 2.25? Equals minus 4x minus 4. Bring it all to one side. 4x plus y. And then minus 2.25 add on 4. Minus 2.25 plus 4. Give me, yeah, I did, sorry, 3y, isn't it? Thank you. And multiply across. 1.75. Read the language of the question. Am I entitled to full marks? Why? Has to be integers, okay? So what would 1.75 be as a fraction if I was to put in? Yeah, so if I multiply both sides by 4, it should actually fix that problem. So this is 7 over 4. You need to multiply both sides by 4. What do we get? 6x plus 7 equals 0. The equations of the diagonals of a parallelogram are x minus y minus 7 equals 0 and x plus y minus 1 equals 0. The line x minus 5y minus 7 contains one side of the parallelogram. Find the area of this parallelogram. Okay. Now, when I'm doing this type of question, I like to get a rough idea of what it actually looks like. Okay. So once again, I'm going to go for y equals mx plus c to explain to myself what does this diagram look like. So here's what we're going to do. I'm going to bring the y over this side. Is everybody happy with y equals x minus 7? Everybody then be happy with y equals minus x minus 1. And then the last one would be third line would be 5y equals x minus 7. And y would equal 1/5 x. And then 7 divided by 5 is minus 1.4. Cool with that? Okay, ready? So when I look at the first line, see this line here, y equals x minus 7? Yeah. Which one? Oh, it's minus x and plus 1. Thank you, Daniel. So just so we know which one's which. See this red one here? That's that one there. This blue one here is that blue one there. And finally, this purple one is this one here. So we know what all three lines are now, yeah? Okay, now I'm going to need 0 minus 7. Now, 0 minus 7 is just slightly below as far as I went down. So I'm just going to put it all the way down here. Is that okay? Because it cuts the axis at minus 7. And what's its slope? Its slope is positive 1. So it's going to go up at roughly 45 degrees. Is that okay? So if I was to do it like this, it'd be like that. And what I'm just going to do is just going to drag it down. It's that line here. Okay with you guys? Okay. I think that's roughly right. Now, yes. Yeah, go on. Now, next one. See the red line? What's the deal with the red line? It crosses the axis at 0, 1. You agreed? And it has a slope of minus 1. Actually, now that I think about it, Liam, by actually drawing this, I'm actually finding the points of intersection rather than doing simultaneous equations. Yeah, because I'm going to draw it accurately here. The only problem with drawing is, do you know, when your answer is a fraction, it's not exact. I'm getting a rough idea of what's going on in my head, right? So we know that there's a point of intersection somewhere here, yeah? And what does it say about the other line? It says the other line is one side of the parallelogram, right? So doing 1.4 is going to be tricky for me. So it's going to be roughly 1.5, yeah? And it's a fifth. How do I do a slope of a fifth? What's the slope of a fifth, lads? 5 across and 1 up. And then another 5 across and 10 across 2 up's the same thing. Now, if I draw this, okay. Now, where's the location of the parallelogram is the next question we're going to ask ourselves. Okay, so reread the question and go, equations of diagonals of a parallelogram. Oh, the diagonals. They're the diag. So, oh, I actually have it now. I think I have it. It's so. Do you see this here? I'm just going to color this a different color for us, all right? Do you see this? See this green line here? That's one diagonal of the parallelogram. And you see this purple line here? That's the other diagonal of the parallelogram. And by logic's sake, the other side would have to be what, guys? What would be the other line? The other line that's containing it? Huh? The other line would be actually have to be at the bottom, like this. And then where would my parallelogram be? You see the parallelogram? Now, the deal is, yeah. So I have an idea. Okay. The idea would be the following. Okay, which points can we actually get? I believe we can get this blue point. How? How can you get that blue point? Simultaneous equation between which one? Simultaneous equation between x minus 5y equals 7 and it's this one going downwards, isn't it? So that's x plus y equals 1. If I do that simultaneous equation, I will find that blue dot, no hassle. Is that okay? So here's what we're going to do. We'll take the bottom one away from the top. And what do we get? Minus 6y equals 6 and a y value of minus 1. And if you want to sub it back in, I'm pretty sure the x value is going to be 2. Is that all right? Is the x value 2? Yeah, it's going to be an x value of 2. So that blue dot is the point 2, 2, 1. Is that all right? Would it be possible to find this red dot? Sorry, not the red dot, I'll think of a different color. See this yellow dot here? How do I find that one? I think it is. Okay, do it. Another simultaneous equation with D. So it's 3 simultaneous equations, isn't it? To find 3 points. Yeah, it's a very tricky question. So let's do that now. So what do we say? The this line here with the slope of what's it? Slope of 1 is the red line, or is it, no? Sorry, it's the blue line. So it's x minus y equals 7, and we're intercepting it with the x minus 5y equals 7. Is that right, you guys? Change the signs on the top one. Add downwards what we're going to get for x. Oh, sorry, not for x, for y. Minus 4y equals 0, and we know the y value equals. And we're not too surprised about that, are we? Because in our rough diagram, it was getting close to 0, wasn't it? And then what would the x value be then? The x value is 7. So that's the point. 7, 0. The yellow point should be 7, 0. How do I find the red point? Intersect the 2 diagonals. Is that okay? So intercept the 2 diagonals. And when I intercept the 2 diagonals, what do we have here? Yeah, y's cancel out outright, don't they? These are hard questions. X equals 4, yeah? And the y value will be, minus 3. So that's 4 minus 3. Now, just something I need to look up, remember, is that the diagonals of a parallelogram divide into 4 equal sectors. So what's my goal now in this question? To find the area of the blue, the yellow, and the red, and then multiply the answer by 4. Would you guys be all right finishing that off yourselves at that point? I think we did the very difficult part already, didn't we? Everybody at home, you're going to translate it to 0, 0, and then just do a half x1, y2 minus x2, y1. Right, good job. So guys, 2 minus 1, not 2, 1. And that's the great thing behind the diagram on hand, because you can actually see if you wrote down the figures wrong or not. Cool.